Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on Twitch. No library, no engine, just us and our code. And we're at the point right now where we're trying to do a little bit of cleanup before going on break. We are going to be on break next week because people wanted some time to catch up, so we're going to take a week off and people can catch up with the series as necessary. So what we're doing right now is we're actually kind of going through and just improving our handling of we're making a 2D game to some degree, but we also sort of have three-dimensional elements in it. And so what we're kind of doing is saying, well, let's go in there and we're trying to figure out exactly how we want to handle that third dimension, how we want it represented, how we're going to handle moving up and down between things, that sort of stuff. So we sort of hit upon something interesting yesterday, and we didn't quite have a chance to really go explore it. So today what we're going to do is we're actually going to go explore that. Before I get started though, just a reminder, anyone who pre-ordered the game on handmadehero.org, if you want to follow along with today's episode, Coding at Home, today's episode is day 74, so you want to unzip day 73 source code into a directory, and then you will be able to follow along with us as we go, because that's the code that I'm starting with today. So let's go ahead and get things started here. I'm going to load up everything that we have going. Okay. So let's take a quick second to recap what I thought was a pretty interesting thing we kind of discovered yesterday regarding how entity collisions are handled, basically. So previously, let me go ahead and start a little place here for us to draw day 74. So what we were doing before, we kind of just implemented some very simple collision things, and I had sort of thought a little bit about some ways we wanted to handle things. And so what we had ended up implementing just for the time being was a system whereby, assuming that you had an entity, and maybe you had, like, here's the hero, and here is the Monstar, and you're trying to attack the Monstar. You do something like you throw a sword, so here's our sword, or S-word as the case may be. You throw a sword, and that sword is going to go, and maybe the sword might want to pass through the monster and do damage. Like it has piercing or something, so it's not going to stop. It's going to go straight through. And we had a number of ways that we could think about handling this, and there's just a lot of different sort of concerns involved in what seems like a very simple thing. If you actually want to think it through and do it right, there's actually quite a bit here to think about. And what I had implemented before is I'd said, well, you know what I'll do? I'll implement a thing which basically says, for any entity, pair, like the sword and the Monstar. When the sword hits the Monstar, I'm going to have a system which is basically like a little record-keeping thing, right? I'm going to have a little table. And what I'm going to do is when the sword hits the Monstar, because I don't want to process the fact that the sword hit the Monstar any more than once, I just want to do whatever happens when a sword hits a Monstar and then be done with it. I'm going to, at that point, when the sword hits, so the sword comes this way, it hits the Monstar, I'm going to go ahead and add into here the sword Monstar entry, right? And then from then on, every other frame, I'm going to look in there and see, oh, sword Monstar was already processed, so I'm not going to process it again, right? Then when we get to the end, and the sword, travels the distance it's allowed to travel and then has to be removed, what we're going to do is we're just going to clear all of the things that were in this table, right? So anything that was in the table, I shouldn't say all things, all the things that had the sword in it in this table, right? They're going to go away. So that was an easy way that robustly handles the case where you have some kind of projectile and you want to process hits in any way that you want. You can know how many times you've looked at something, you can do all kinds of stuff because this table can store whatever we want. And it persists through the life of that hit. Now what we wanted to do yesterday was we wanted to say, let's have a stairwell, right? Something like this where you're kind of like going down into the abyss, right? Here is the abyss, or just the next floor. And so you're going to walk down the stairwell, and what we wanted to have happen was say, okay, if here's the hero, right, and they're walking in this direction, this is top down now, this is from the top. If we're going to walk in this direction, what I want to do is say, well, when the hero overlaps the stairwell, then I want him to be able to move downward. I want his Z to go downward as he sort of overlaps that stairwell, if that makes sense. So when he gets higher, when he gets to here, I want the z value to be the next level down, and when he's here, I want the z value to be essentially where he currently is. Pretty basic, right? But we want a system that allows us to write code like that very easily, so we don't have to do a lot of thinking about it, right? We don't want to have to do a lot of work to implement things like that. We want our collision detector to make that easy for us. And so what I was going to do is I was going to say, all right, and we sort of started coding this yesterday, all right, we'll have a notion of whether things are inside or outside of things. So at the start of a frame, we'll basically do a test to see what's overlapping. So, maybe the hero's here at the start of the frame. We'll say, okay, he's overlapping the stairwell. And then at the end of the frame, we'll basically say, okay, if he's not overlapping the stairwell anymore, that's fine, or whatever, and we can process what's happening during that sort of that movement, right? Excuse me. So that's kind of like what we were sort of talking about doing in the processing of the movement of the entities. And what I realized when I was doing that was like, well, wait a minute, can't we just use this table directly? Like, can't we just use the table when we start up and say, okay, when we're overlapping something, let's add an entry to this table, and that way there's somewhere to store information about it as well. And then when we're done, we can remove stuff from that table. That way, we're always using the same thing. Instead of having some kind of special handling for things that overlap, we just have a table which is basically telling us about the situations that these things are in, and we just use that. And that seems like a pretty good way to go to me. That just seems like a good way to go. So I don't really know. That's just seems like a good idea, and it seemed like that was going to make things a lot more unified and clear if we did that in the code. So that's kind of what I want to explore today. But other things that I was thinking about as well were things like, okay, so when the hero is traveling inside this region and we want his z to be mapped to where he is on this thing, we have sort of this other kind of I don't know how you want to phrase it. We have this other sort of special. We almost want to do a little bit of special processing because of the fact that these stairwells, if we look up from the side view, right, because we kind of want to treat them as ramps, basically, when we do our movement processing, our movement processing is going to work like that. And really what we want our movement processing to be doing is something like that, right? We want it to move the same kind of rate, so we want it to look like that, right? That's what we'd like to do. And so one thing that I was thinking that we could do as well is we could sort of say, okay, if we have our movement code, when it does the move, we've got this sort of region check that says, are you intersecting the stairwell? If you are intersecting the stairwell, we could do that check again for the destination point, and assuming that the destination point is still within the stairwell, right, we move it down to that position, or something similar to that, right? And that way we can get some, and I guess we should say, we move it down to that position, right? I don't know, it's kind of complicated. It's starting to really do like full 3D processing sort of on the movement of the guy, which maybe we don't want to do. Maybe we just don't want to deal with that or get into stuff like that. But I was just thinking about it, and I was like, well, if you really wanted to handle this correctly in terms of how you would conceptualize the problem in terms of a more realistic simulation of what happens when someone's going. You could imagine us even going a little further and saying that there actually was an actual stairwell, and we actually looked at where you were, and the z was like quantized, right, to like certain stair steps. So the hero goes like ding, 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 ding. We can do that as well. There's all sorts of stuff we could do there, right? And I don't know how far we want to go down that path, but it's just something that's worth noting. Finally, there's the easiest thing which I thought of, which is actually a way of cheesing out on all of this stuff. And I don't know, maybe this is a better way to do it, and we could do it this way right now and just put a note in. I don't know. But another thing we could do is, instead of processing at the beginning of the frame, instead of allowing the person to leave or enter the stairwell inside the collision iteration loop, right? What we could do instead is just treat that as something that only gets checked once. So basically, at the beginning of the frame, if the guy is on the stairwell, then just whatever the move is just considered a stairwell move. So the stairwell basically gets to do its operation to the guy, whatever it's going to be, at that outset, and that's all there is to it, right? And, that's one way we could process it. And then we just say, okay, he doesn't, until he actually is outside of the stairwell, on the next frame, that's, if he moves outside the stairwell, then on the next frame, he won't be under the action of the stairwell anymore, right? I don't know. Again, just something to think about, and that may be the easiest way for us to implement the stuff for now. I really don't know which of these is going to be more interesting, and you can certainly imagine this kind of applies pretty easily to other stuff too. So let's take another case. Let's say we take the case of like poisoned ground or lava or something like this, right? So let's say we have lava here, right? So this is our lava, right? It's so hot and burning, it burns me, right? Ouch. And so, we have our hero, and our hero moves into the lava. And our hero travels in the lava, and the hero moves out of the lava, right? So if we want to process this exactly right, what we need to do is handle that case where the person enters the lava, and handle that case where they exit the lava, and actually count, if it's distance or time-based, actually count exactly the period where they're in it in order to apply like the lava damage, right? The cheesier way to do it is the point sampling way. And the point sampling way basically says, okay, I'm going to count however many of these land in there. So at the beginning of every frame, this is not in the lava, so it doesn't take lava damage. This is in the lava, so it does. This is in the lava, so it does. This isn't in the lava, so it doesn't. Right? And so, again, this is just a question of how, intricate do we want to make this? And so if we only want to do the point sampling method, then basically what we would do is we would say, all right, there's a separate check, right? Separate check, where we check for inclusions in spaces like stairwells, lava, anything like that aren't collision events. So people don't collide with the lava and like enter and leave it or anything like that, right? That doesn't actually happen. All there is an inclusion check that happens separately, and then, off you go. And so that may be a better thing for us to do for now. I don't really know. Where we basically say, okay, we'll do the for now, we'll just say we'll do the separate checks. It's easier because we've already done the code for that. And each time we check, we'll just pass the full DT for the frame as the effect time. So if we had like a thing that was like apply lava damage, we'd tell it the whole DT for the frame, apply the lava damage. We won't try to subdivide frames and figure out exactly how much of the time was spent inside the lava and out. But maybe we'll put in a to-do that basically says, okay, maybe we start leaning on the sort of the table-driven system and try to do some more intelligent stuff there that would allow us to, be smarter, basically, about that. Just something to think about. So I don't know. I really don't. I have no real opinion about how that should work. It's just going to have to be a wait and see thing. So maybe we do the simple separate check first, and we make a note, and then we see if we want to go the table route. I don't know. That seems like the best call to me right now, because until maybe we get a little further, maybe eventually it'll become clearer exactly what we need because of other things, and then we'll go on from there. And so sort of what I was saying is like, okay, when we do this check for initial inclusion, instead of doing all this other stuff that we were doing in here, where we were doing our overlapping entities and this sort of stuff, where we were sort of adding and removing things, what we could do instead is sort of reverse back to the case where we weren't ever doing that, and we just add the collision rules or something like this. And we don't actually update that overlapping list. So we just say, okay, we don't update the overlapping list. We don't pass was overlapping. So let's see where that was. We don't need to do any of that. So when we do our handle collision call, we don't actually need this was overlapping stuff, like so on. And we just let it do its thing. and we leave it at that. So now a stairwell is no longer a thing that does collision at all, right? It's not a collision-based object in any way. I don't know how we were planning on doing this exactly. We'll have to take a second at the end of this to sort of clean that stuff up a bit. But basically, so right now what we'll do is instead change this to basically like handle, I don't know what you want to call it, but handle overlapping events, right? Or handle events based on area overlapping, or something like that. And so what we can do here is say, all right, we're going to go through, and we don't really need to record anything per se, but we would go through and just say anybody who does movement has to obviously have a thing here where they're going to check for all the things that they could be sort of overlapping. And for anything that they are overlapping, we process a rule. So it's basically like a handle overlap kind of a thing, right? And so what I'd like to do is say this is going to happen before we actually try to take any step, right? So this is going to happen like right at the beginning, right? Just flat out. So right here, before we do anything else, we're going to go ahead and we're going to see if we're overlapping anything. So we'll call that handle overlap. We will pass it exactly the two that are overlapping, and we'll say that we kind of have a notion of who is moving. So the mover and the region or whatever, right? And we'll do like a should overlap as well, or like can overlap, right? And so the entity, the thing that's moving, is always going to be primal in this case, and we're going to handle it that way. So we do, we always say that the can overlap and the handle overlap are both going to, kind of do their thing. So we'll do it that way, and then we'll have our should collide, right? I guess we should keep our name consistent there. So should overlap. It's really should overlap test. It's just a bad name. I wonder if it shouldn't just be can, right? Can. There we go. That seems better. Should collide. Can. All right. And in fact, I guess we don't really need this at the moment either. This is just can collide. Okay. So if I do that, then we've got our can overlap and our handle overlap. This is not important anymore. And there we go. Except I need can collide to be changed its name here. And presumably I need to pass that in here. There we go. All right, so now we need to, I should also probably just double check that we didn't break anything doing that change. So let me just go ahead and make sure that our code is still happily running. There it goes, and that's all good. So now what we need to do is just say, all right, we're going to test the entities. We now know, they're going to overlap, and I'll just write a function which handles the entity overlap such that if a hero or any other thing overlaps a stairwell, Z gets moved downward or upward, depending on where it is, right? And that seems pretty straightforward. Unfortunately, we're going to have to do some work to actually make the rendering show us that to any real degree. We don't have much in the way of that yet, but that can always be our next task. Move and region. Call that mover and region. So the thing that's moving and the thing that ends up overlapping. So basically, if the region, right now we don't have anything really here, but essentially we're just doing if the region type is one of those stairwell regions, then pretty much that's the only case that we actually need to handle at the moment. But the lava case would be another example here of something that we want to do. So we've got our handle overlap as well, and we will build that out. That's again just taking whoever's moving and whichever entity it is sort of moving, or it is contained in. And I also said, like I was saying before, I want the time step in there in case there's a time-based effect that's happening. That way it applies it for a period of time so that if we do decide later to handle it a little more accurately, and in fact I'll put that to do in here, to do handle overlapping precisely by moving it into the collision loop. And you know, we'll just keep improving things as we go if we decide that's a good idea. All right, so anyway, if it's a stairwell, the result is true. Otherwise, the result is true. Otherwise, the result is false. So that's pretty straightforward for now. It'll presumably get more interesting later. And then when we go to handle the overlap, what I want to do is say that assuming that the region is a stairwell, then I'm going to do that processing where I'm going to effectively change, and I'm assuming I'm going to basically change the position and perhaps also change that velocity to be pointing downwards as well. You know, I'll just take a look here at how that works. So the DDP, let me just see what we're doing here. So the DDP is passed in, right? Is that what happens? So we're passing in that acceleration. And so the acceleration gets gravity added to it as well, right there. I mean, I suppose, really, all we would have to do if we wanted to is modify the ground location when you were on the stairwell, right? Because this code right here actually will just do what we need it to do, scary as that is. So I wonder, I mean, it sounds a little odd, but like, I wonder if we don't just want to do it that way for now. So in other words, you'd handle it at the end of the frame. It'd be backwards looking. You know, don't love it, but, and you basically say like, where's the ground? The ground's at 0, 0 or something like this, right? You see what I'm saying? And then you would basically update the ground inside that handle overlap call. It's kind of weird, but it sort of starts to get at what I would like, which is, you know, a notion of where the ground is. So maybe it's not that crazy, and it's probably not exactly how I don't love the way it's kind of weird, but you know, in this 2D thing where we don't really have a strong notion of where the ground is, we're gonna have to kind of build a semantic understanding of ground that makes sense everywhere. And so I'm just gonna kind of let this go. I'm gonna see where it leads, because I'm hoping that eventually it will sort of coalesce into a nice way to handle ground. Again, like I said, I normally program 3D stuff, so I'm used to having to think about a ground as like some full 3D thing, and in this case, that would be a real waste of time and energy for the game to even have in it. So it seems like you'd rather just have the ground is always the ground, and the only time that you really do anything else is when you're on something special, like a stairwell or some other special sort of Z-affecting thing. So, yeah, I guess we'll just say, you know, we'll go ahead and say that we've got ground here. We could even make the ground be a general query. I guess we could just make actual ground shapes. And I think that seems like a waste of time. So I'm thinking you only really want to handle colliders. Yeah, so I'm just going to keep exploring this because I just don't feel comfortable yet. I don't have a solid idea of exactly what I want. So I'm gonna keep on pushing here, and we'll see what happens. So for now, I'm gonna pass the address of ground so it can modify it. But later, what we might do is pass kind of a bundle of stuff to that handle overlap and let that do it instead. So yeah. So what we'll do here is we'll just say, all right, you can modify the ground level. So what we'll do is we'll come up here and in our handle overlap call, we will pass in that ground level. So, and if it's a stairwell, then what's going to happen is we're going to find out where you are in the stairwell and set the ground level accordingly, right? And that also brings up another thing, which is I've realized how we really should be drawing stairwells, which is not with a stupid rock, which is what we were doing before, but it's really actually with a rectangle. What I should have been doing was using a rectangle. So I'm going to take a look here, let's see about drawing a rectangle. I know we've got one in our draw hit points function. So I'd like to do one of these push rect calls. Oh, wow. Just the other night, someone asked about vector 4s, and I was like, eventually we'll put some in for handling colors. It looks like we already did, and I totally forgot. I knew we eventually would, but I guess eventually was actually in the past. So whoever asked that question, not only eventually will we put in colors, we actually already put in colors as v4s. There you go. You learn something about your code base every day that you should have known because you wrote it. Anyway, so I'm going to go ahead in here and I'm going to say that we're going to draw that stairwell as an actual rectangle now, so that we don't have any of this weird wondering exactly what its dimensions are. That'll just help me to debug it, basically. So I'm going to do a push rect on that piece group. We've got basically a location that we want to draw, and then we've got a dimension. I don't remember at all what we actually did for our conventions here, so I'm just going to look it up. It says basically that we pass the group. We pass where it is, I assume relative to the camera. Oh, it's relative to the piece. So it's actually just the center, right? It's no offset. We've got the offset Z, which again, we don't really need any of. It can just be drawn flat on. And then we have its dimension. And so its dimension is just going to be its entity, actual entity dimension, right? So that's just going to be entity dim xy, right? So then the color, we'll just draw a yellow there so we can see, and that should be just about all we need, I think, to get our stairwell. So let's take a look at our stairwell. There's our stairwell. That's good. And so what we want to do is be able to move onto that stairwell and just kind of like move onto it and have it allow us to move not only through it, but basically like to move down a level as we go. Or in this case, I guess up a level. So that should be relatively straightforward. However, what we do need to do is we need to be, I guess this gets actually a little bit complicated. A little more complicated than I was thinking, because we do have one other case that we can decide how we want to handle, I guess. But basically, the last thing that we do have to worry about is when somebody moves onto a stairwell, right? There's two ends to a stairwell. So I guess we could look at it from the side view again, right? So there's two ends to the stairwell. And let's say that somebody's walking up here, right? Because here's the floor or whatever, right? If somebody walks, whoa, that was ugly. I don't know what just happened there. So somebody walks here. We don't want them to snap down to here because they shouldn't be able to do that on the stairwell, I don't think. What we'd rather do is prevent them from walking there, right? We want to stop them. That should hit and stop. Whereas if they walk onto this end, then that's fine, because then they just go down the stairs like they should. So the question is, how do we want to handle that case, right? So at first, I'm not going to handle that case, but then we've got that issue, which is basically you can just walk straight onto it, and we'll see what we want to do. What we could do is put in blockers that block you from doing that, and the stairwell is a hybrid of that, right? And then the other thing we can do is handle it in the actual stairwell processing so that the stairwells understand that. And I don't know which one of those two will be more logical, but, we'll find out. All right, so if we do this, now I think we're good to go with drawing it. So, oops, what did I do? I accidentally typed a U. So really all we need to do here is just say, okay, where is the guy inside this region? And in order to do that, what I want to do is introduce the concept of a mapping for any rectangle. And because this is just kind of a thing that might be handy and we need it for this case, so we might as well do it. What I want to do is say, all right, for any of our three-dimensional rectangles, which we now have, right, I want to be able to say there's a minimum corner to this rectangle, right? Let's say that this is our minimum corner, right? And here's our x, here's our y, here's our z, right? And so this minimum corner, and then it has the dimension is the distance over to the maximum corner, which we'll say is here, right? What I'd like to be able to do is, given a point P, right, let's say that this point here, I'd like to be able to produce what amounts to barycentric coordinates for this rectangle, meaning coordinates that range from 0 to 1, right, our famous 0 to 1, because everything is nice in the 0 to 1 range, right, range from 0 to 1, and which represent how far along each axis of the rectangular, the right rectangular prism, this shape, how far you are, the box, right? So basically, if in X you were here, then you would be something like 0.4, right? If you were here, you'd be like 0.8. If you're here, you'd be 1. If you'd here, you'd be 0. And the same on all the other axes. So we'd take what's a normal 3D vector, right? And we want to produce those. Now, how do we produce those? Well, the first thing we want to do is recognize that the minimum is 0, 0, 0 in our coordinate system, right? When we're saying we want to produce these new coordinates, we're saying that if you're at the minimum, right, you would be at the barycentric coordinate 0, 0, 0, right? And I'm saying barycentric, but that's probably not really necessarily a useful term to use here. So I guess what I just want to say is, in some sense, relative normal coordinates. Relative meaning they're relative to where the box is. So the box may actually be out in space. The origin may be like over here somewhere, right? So this may actually be 0, 0, 0 in our coordinate system. And this is the minimum of the box, right? So the box is actually out here somewhere. But we want to create a little mini coordinate system, essentially, where the minimum corner of the box is 0, 0, 0, right? So it's relative. We're producing relative coordinates. And we're producing normal coordinates. Normal meaning they are normalized, right? Meaning they are between 0 and 1. So even if this box is 10 meters long, I don't want it to be 10 when it gets to here. I want it to be 1. So how do we make it relative? Well, trivial. We just subtract the place that we actually want to be 0, 0, 0, right? Makes perfect sense. Because if we know that we want the point min, right, in our coordinate system to map to 0, 0, 0, then min minus min obviously equals 0, 0, 0, right? So what we want to do is just subtract min from our coordinate system. You could think of this, you could do this in algebra too. If you wanted to sort of, let's say you just had no idea, you're like, I don't know how to do that. You could say, well, I've got a point. For any point, right, I want to basically add something to it. I want to do some kind of translation, right, for our question mark value, whatever it is, we don't know, some v. For every point, we want to add some v, okay? This is our expression. And we want that point to equal our relative coordinates, right? So this is our relative coordinates, or we could say p prime. So these are our relative coordinates. So what did I just say? I said when we do min, we want that to be 0, 0, 0. Well, just plug those in. When I pass the point min, right, I get 0, 0, 0, right, or the 0 vector. That means min plus v equals the 0 vector, right? Solve the equation for the thing we want to know. V equals 0 minus min, or negative min. So that lets us know exactly what we need to do. We need to subtract min from anything we want in order to get it centered around this thing, right? Simple enough. But now we have coordinates that can be anywhere in this box. They happen to be 0, 0, 0 here, but they could be as long as they want. And again, how do we normalize something? Well, we know how to normalize things, right? If you have something of a given length and you want to turn it from 0 to the length into 0 to 1, you just divide by the length, right? We've done this a bunch of times with like vector lengths and all that sort of stuff. So we have, right, our point minus our minimum divided by however long that point was, right? For any given, so it's kind of hard to, sorry, not how long the point was, how long the min is, right? We want it to be relative to this. We want it to be relative to the maximum extent of the axes, right? So over however long the min is, that gives the new coordinate, right? So px min x, right? This is basically the equation for one of the x's. The same is true for the y's and the z's, right? So subtract them in, divide by, you know what? I don't even know. What am I? I'm going way too fast here. This is not even, this means nothing. What have I written here? There's no such thing as the length of min. We already said that's stupid. Pretend I never said that. That's not what I meant. I meant the length of one of these things, right? That's max minus min. Yeah, going too fast. I got carried away. It's true, right? Because if this is the max x coordinate and that's the minimum x coordinate of the thing, then the length between them is the max minus the min, right? So little mistake there. Pretend I didn't say that. So that's what we want. We want that max x minus the min x and so on. So that's pretty easy, right? It's not complicated. It's very straightforward when you think about it. But I want to make a function that basically does that so I can grab that value anytime that I want. So what I'm saying is I want to basically do v3 get, let's say barycentric, and then we'll pass some rectangle and some point, right? And then what we're going to do is for each of the coordinates, we're just going to go ahead and make those coordinates be equal to the equation that I just said, which is, you subtract the min, so a dot min dot x, like so on, and you divide by whatever the length is, right? So a dot max dot x minus a dot min dot x, like so. And that's just going to be, oops, shouldn't have done it that way. There we go. And that's pretty straightforward there. Now we do have one problem, which is that in the case where these were 0, like one of the dimensions was collapsed, the entity didn't have any size there, that would be illegal, right? This would produce a nonsense value. So since I don't know that we really have a performance concern here, I'm going to introduce another thing that we can do to make this a little bit more robust to those kinds of failures, which is a safe ratio function. And the way that I like to do these is to say you pass a numerator, and you pass a divisor, right? And it does a divide for you. So basically it just does the result equals the numerator over the divisor, right? Like so. And it returns that to you, but what we can do now is we can say, all right, this safe ratio will be designed to return a particular value in the case where the thing doesn't actually work, right? So if that divisor is not equal to 0, we'll do the divide. But if the divisor is equal to 0, we'll return some prefab result. And so safe ratio 0, I usually do that as well as a safe ratio 1, right? That would return 1 in the case, depending on what the default value should be. And so one thing that's pretty handy to do usually is to do safe ratio n, and then that just returns whatever the n is, and then I make essentially inline versions of the other two that just return those prefab values, right? Does that make sense? Hopefully that makes some sense. So basically it just goes safe ratio n, and it passes the numerator, the divisor, and whatever the value actually is. There we go. Return result. And so again, this is for cases where you're less concerned about performance and more concerned about robustness. You don't care if you're doing a bunch of if checks to see what the situation is. And in this case, I think that's probably where we would be most of the time. And certainly, and we had a case where it was a performance problem, we just optimized that one case, right? No big deal. So let's just go ahead and say that these are all going to be safe ratios. And so that way, in the case where they actually have a problem, they'll be okay. So if one of these dimensions is, erroneous and collapses to 0, we'll still be able to produce a value there. So that seems fine to me, right? Safe ratio 0, safe ratio 1, result equals n, divisor not equal to 0. Yeah, so that's all good. And so that allows us to do our barycentric here. We can say get barycentric, and this will give us our barycentric version back. So now we can say that we have the region's dimension excuse me. This is kind of a little bit of a roundabout way to do this, I suppose. If you think about it, well, I think we have center dimension, right? So our region, we pass in basically the rectangle bounding box that represents the region, like so. Then we just say wherever the actual mover was. We get those barycentric coordinates back. And one thing we can sort of do here, we could also assert that they lie between 0 and 1, because one of the things that's true about this is this will not clamp those values. I don't know if we want to clamp those values. We could, right? We could additionally say that they have to be between 0 and 1, because let's say that you pass in a p that's actually outside the box. It would not clamp it to the box. So maybe we want to do that eventually. I don't know. In this case, we're only handling it when we overlap, so we know that pretty much does have to be. So what I'm going to do is say, all right, we get that barycentric back. Now we know where you are, and we're saying that y, I guess, is our range. You know, y is the thing that we want to vary. Z by. So what we're going to do is we're going to say that whatever that y value that comes back, that's how far, right? That's that barycentric y value is for our stairwell. That barycentric y value is how far you've gone, right? So here's one end of the stairwell, here's the other. So let's just say that we take that value and that determines that z value of the ground, right? So what we want to do is say that the ground equals the barycentric v value, y value, and we want to do essentially a linear interp, or a linear interpolation, like a lerp here, right? And what a lerp is I've talked about this many times before. It's that magic function that I said we would use everywhere and have used multiple times already and will continue to use a bunch of times, right? It's this thing, 1 minus t times the starting value plus t times the ending value, moves you between two values proportional to this t, and the t ranges from 0 to 1, right? You've seen it multiple times. If you don't remember it, now would be a good time to go back for a refresher to where I've talked about it before, or watch the interpolation video that's on my thing. I have a whole video that's just about interpolation. But anyway, so what we want to do here is say this t value, right? The t value is our y. That's our y value, how far you are in the thing, our barycentric y. And the s and the e are the z values we want. So this s value would be like the z min, and the e value would be the z max for the ground, right? And so as you go up. We could also make it the other way. As you go down. Who cares? Doesn't matter for our stairwell. It would be nice to draw it in a particular direction. So we probably could do something like that, where we try to draw it a little more clearly which direction it was going. I can think of a pretty easy way to do that. Maybe we'll go throw that in. But anyway, so what we want to do is we want to do that linear interpolation. We haven't made a function for it yet, but we should throw one in here, right? That's just an easy way to sort of do lerps, especially 2D, 3D lerps, that sort of stuff. We probably want all of those, right? So where is our squaring function? There it is. Let's make another one here, a lerp function. So there's our lerp function. It will go from A to B, like so. So here's our result, and our result is just going to be that 1 minus t plus t times b is exactly the thing that I just said and that we have used before. That's going to be the value that we get back. So we're just going to go ahead and lerp using that barycentric y coordinate as a lerp. We're going to lerp between our z min and our z max. So our z min is whatever the region's p z value is, right? Plus, or I should say, actually, we can actually do this right with our rectangle. So if we remember what our rectangle is, right? Here is our region rect. Region rect. Now we can just say, okay, the region rect, its min z, and the region rect's max z. That will just lerp between those, right? And that changes the location of the ground. And now, since the guy is always pinned to the ground, basically he'll just snap to the ground. Now, unfortunately, like I said, we don't really have any good rendering for this stuff or anything like that. Of course, we need one more thing too, which is that the guy can't hit the stairwell. So we need to actually make this so that this isn't actually in the collision. This is actually in can collide. So what we want to do here is say something like this: result equals false, like that. All right. So I think now we should be able to walk through the stairwell, I hope. Oops. Oh, guess we set a breakpoint there. I don't know why. We must have done it before. So why am I still colliding? Can collide should be returning false now. Oh, is it because I didn't sort those two guys right? Yeah, that's because this isn't sorted. So we need to do this either way. So basically what we need to say is if it's a stairwell at all, you don't want to do it. There we go. All right. So now, in theory, we should be able to do something where we look and see how our stairwells are working. We should be able to get these working. We're going to need some way to actually render where we are in Z, which I guess is our next step. But at first, we can at least go into the debugger and see whether we're actually handling the stairwells by inspection at all, right? Because we just wrote a bunch of code there and we have no idea what it does or if it works. So let's go ahead and actually do that. So we got our can collide, our handle collision, and we blah, blah, blah. This is what we want to see, right? Oh my. What is overlapping the stairwell right now? Dare I ask? Why are we getting called right at startup? Handle overlap. Oh, because we don't check for... Yeah. All right. That's a problem. We don't check for things overlapping themselves. Can overlap. Right, we remembered to do this here where we did the sort of A not equal to B. So we did this, right? But we did not actually do that for the overlapping. So what we want to do is say that things that are, you know, obviously things that are the same thing can't overlap with each other. Of course, now that I think about it, why are stairwells moving? Oh, because everyone gets moved now? We should probably have a thing that says that stuff like stairwells don't move, right? Like, we probably need a flag for that, because we really don't need to call move entity on these sorts of things, right? So we want to say that if that's not set, and probably we want to do something here where we do like entity flag movable or something, right? We probably want the concept that something can and can't move to sort of be baked in there in some sense, right? Entity flag movable equals like that. And then only like our Monstar, our familiar, those sorts of things would have that. So let's double check that. Sorry, we just never did that. And I was like, why was that thing even getting a move call? So now nothing should be able to move, presumably. No, but it still is. So what did I... Oh, it's right. It's supposed to be is set movable, not is not set. That's kind of obvious. Sorry. There we go. It would be non-movable. All right, so nothing can move now, which is what I wanted. And now we can just go in and say when we add things like the Monstar, add Monstar, we can say that, you know, it collides and it is movable, right? And I don't know, does add flag allow multiple adds? I assume it probably does, but it's not called add flags, is the thing that's a little bit weird, don't you think? It seems a bit strange. Add flag, oops. Add flag. Where is add flag? Grep, add flag. So yeah, this is really add flags. So we should probably say that for now. Let's take a look at that. Add flags, clear flags, clear flags, add flags, 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 flags. There we go. So that way we can just kind of go like, okay, we'll just put both in there. Same thing with the familiar. Oops. And the player and the sword should also be in there, I would think. Right? There we go. We got to clean those flags up because the collides thing is now all kinds of weird. Because we're sort of working on what those systems even mean. All right, so now in theory, we should be able to actually do something with the overlapping. So let's see what we've got. All right. So here we are in our sort of barycentric mapping code. Let's see what we got back. So that's just totally wrong, if I'm not very much in error. So we have a bug here because Our y value should not be negative. Oh, you know what? It totally can be negative because these are regions that are overlapping. So yeah, right? Like, that's totally true. We already need the clamp thing. I said we didn't need the clamp thing. You shouldn't listen to me. This is why you don't listen to Casey. Believe the debugger, because the debugger is right. So we've got a situation where a guy can be overlapping the stairwell, right? But his point is not in the stairwell. So it seems like we really do want to clamp the value to the minimum and maximum of the rectangle. So we do want clamped barycentric. So yeah, let's go ahead and do that. We would have needed that anyway, so no big deal. Handle overlap. Let's do get clamped barycentric, and we will go ahead and I guess we could also do how do I want to do that? I could just do it this way, right? Something like that. I think I like that better. Let's do it that way. So inside the math functions, I'm going to go ahead and do a little clamp function here, which we may want to do something better for in the future, right? In terms of how we implement it. But so what we want to do here is say, all right, we're going to have a result. The result is going to be equal to the value, but if the result is less than the minimum, the result's going to equal the minimum. And similarly, if the result is greater than the maximum, the result's going to equal the maximum, and then we will return the result, right? So I think, we could do that faster with SIMD. I don't know if the compiler's smart enough. It probably is. Who knows these days? And then what I'm going to do is I'm just going to introduce a clamp that's specialized, again, for 0, 1, because that's a very common thing that you want to do. So basically, you just pass a value. And that value, sorry, you just pass the value, and that value will automatically have the 0 and the 1 passed with it, like so. And that will be the result of that function. Return result. And then what we'll do is we'll just actually have the, oops, what did I do wrong? Oh, no, that's fine. And then what we'll do is we'll just have this for our various v2, v3, v4s, that sort of things, right? So for now, we'll just go ahead and say, all right, we've got that clamp 0, 1. That will take in a v3, and it will return a v3. And the result.x is just the clamp 0, 1 of the input x. Just clamp each of its elements like so, right? Y, z. And done. So now we should not have that problem, right? Where's our, oh, there it is. So now our y should be 0. It is. Off we go, right? And now our y is actually coming up a little bit. So let's take a look at what ground actually equals. So when we ask where the ground was, where the ground was originally, it should be 0, right? Because that's what's normally set to. And when we're done with it, the ground is negative 0.52. Is that sensible for our ground? I'm not sure. Let's take a look. Where is our region? Region P. Its z is at 0, and its dimensions, yeah, so that is actually reasonable. But that also means our stairwell's probably not positioned quite right, because it looks like where we've actually put our stairwell is in the wrong place. If this is one level, this is one z level, and this is the next z level, it looks like the way I did it, was I put the stairwell like that. But we really want the stairwell to do is something more like that, right? So that was a mistake. That's a little bit of a mistake. So let's go ahead and try to fix that mistake. And actually, even to think about it a little further, we really want that stairwell to include a pretty wide, we want it to test for a fairly wide area, but then only actually apply z from here to here. So what we may want to do is have a separate dimensions for the stairwell and the actual locations where the guy is going to move along, right? But that's, 6 of one, half dozen of the other. All right, so anyway, we now have our stairwell. We need to go in here and see about where we're actually putting it. Add stairwell. Let's find out. Add stair. And yeah, so that's just, yeah, right. We wanna do a thing basically where when we add this guy, when we get this chunk position from tile position, we want to do an offset of that. So we don't want it centered around the Z level. We want it to be staggered. So I'm going to do just because I can, because I'm the programmer and I get to do whatever I want, is I'm going to go ahead and say that our tile depth in meters here, I'm going to go ahead and say that we're going to offset it, right? So we pass an offset, and the offset is going to be this. So if it's at that Z, we're going to offset it up by half so that it's in the middle there between the two Z layers. That seems like a better plan to me. So if we do that, then what we need to do is update that chunk position call. So in our handmade world.h, right, our chunk position from tile position, chunk position from tile position has to take additional offset, right? And the additional offset is just going to be added straight up, right? And this will be defaulting to the null vector, so people who are calling it don't want to do with that at all, they don't have to. So that, I think, would make it a little bit more like what I was expecting to have happen, because now if I restart so that it's in the new place, oh, it's not showing up though. Did I offset it somehow too far so it's not included? What did I do? That should still put it, right? That should put it, that should still make it so that it's actually inclusive, right? You know what? We may have one more thing we have to do for our Z. When we actually gather all of our entities, are we actually gathering in the Z bucket properly? And I don't know, right? It's this thing, min chunk P. Yeah, we're not. We're not at all, right? We are purely fabricating that Z value, which is garbage, right? This should actually be looping over all of the Z's that were in our min and max chunk values. So that's a holdover from when we weren't actually doing any Z stuff. So yeah, that's one more thing that we didn't really think of, but is definitely something that needs to happen. Now what I don't know is how we're actually computing these bounds in the first place. The camera origin, the camera region, not really sure what we did with Z there, right? What did we actually do for camera bounds? So we did a tile in either direction, I guess. Or center dim. Yeah, so we did half a tile in either direction. I don't know if that's really what we want, but at least we've done something. So there we go. Oh, that's hilarious. So our Z sort of already worked a little bit because it's offsetting those guys by their distance down. So we're actually seeing two levels at the same time now, which is kind of cool. That's funny. I didn't realize that would happen, but it did. So now we're gathering both the entities on the top and the bottom. That's kind of funny. All right, well. So in theory, we should be able to move up and down here, but we don't actually, I don't actually know if we are. So we can't go through there because it's blocked. If we go through the other direction, can we now go through it? No. So let's find out why we're not going up and down here. Let's see. So are we in handle overlap? So we're not actually overlapping this thing. So our test for overlapping must not be actually hitting, right? Our overlap test. What do I want to do to check that? So rectangles intersect. How are we doing our test? So that, it's a pretty tight thing that I asked it to do, and it's probably not how, like I said, we'd want a wider range for doing that inclusion testing. Because if the guy's right on the z value, then, you know, that's a little bit iffy. But at the same time, he should be right at z equals 0, right? And so if he's right at z equals 0, it's still, that test should still be passing. So I kind of want to see why it isn't. Let's just go a quick second into the Q&A, because I just want to see before we end for the day and pick up that debugging tomorrow. I just want to see what exactly was happening there. So I set a breakpoint in the hero code and go ahead and run that. I'm going to go ahead and now see when we step into that move entity call, I'm going to go ahead and see what's happening with the overlap test such that it fails, right? So we come in here and we're going to do this right down here, so right here. So let's go ahead and do that, and the can overlap thing should happen. There we go. And now we should be testing against the stairwell, right? So let's just double check that that's what we're doing. So the entity type is the hero. The test entity type should be the stairwell. So there we go. So let's see what our two rectangles are. So there's our entity rect. There's our test entity rect. And let's see. So the problem is our entity is slightly below the Z line because he hasn't been, okay, so that's the problem. The entity had gone below the Z line, right, because he hasn't been clipped yet. And so he doesn't hit the stairwell, which I guess is going upwards, right, and is placed at Z equals 0. So it's worth noting that this is kind of a tricky situation, right? If we're, you know, this is, again, sort of underscores the trickiness of semantic Z handling, where we're basically saying, all right, we don't really have a concept of ground. You're just kind of walking along it. And so I wonder if we need to do something where, like, that ground support, yeah, I don't, I mean, that sort of argues for doing the test at the beginning and picking the ground support based on that somehow, right? And I don't know if that's, I mean, that's the cheesy situation. That was where I had it originally. I don't know if that's such a good idea, because it seems like you want to end him on the ground where he is. So I'm not sure. I'm not sure what the right fix is for that yet. Because again, I want something that feels solid to me. I don't want a super janky concept of where the ground is. So, you know, that starts to sort of feel like to me that I need a little bit more of an intelligent sort of handling for that groundness. And maybe the Z needs to be dealt with a little differently. Like maybe it was a mistake to integrate the Z in here. Maybe we don't want Z motion in there. Maybe we always want two-dimensional updates, and we don't do three-dimensional updates, and then we handle Z after the fact. I don't know. The trivial solution here, obviously, is to make the stairwells a little bit bigger, right? The super cheesy thing is we just make the stairwells handle that, but that's really lame. You know what I'm saying? But that would do it for now. So if I did add a stair where we do this, if we made this a little bit bigger, so instead of it only being that long, you know, it's a little larger, right? And I'm gonna put it to do, Casey, this is extremely not cool. Figure out a better ground update solution. I believe that would fix our problem there, right? Let's see here. Yeah, so there we go. And now we're actually lerping properly. Of course, yeah. Whoa, what's going on there? There we go. So let's see. So we can't go through here now. And then let's see if we can walk up the stairs. Is that up the stairs or is that down the stairs? I don't know which way the stairs go. I have to think about that. I assume that's... So we're still not quite doing what we want. Let me see what happens when we do our lerp. What's the ground value? 0 it should be, right? And we do it at 7. So we should be going up. Let's see what happens. Oh, well, that's one more thing we have to finish before. All right, promise this is the last thing, but I just want to see if this works. So yeah, we actually need to use our ground value, to say the least. All right. So let's see here. Does that work? Oops. And the stairwell does go up in the up direction at the moment. So there we go. Let's see here. So that goes up and that goes down in theory, right? I wish I had, I'm gonna need some way of telling because I can't really tell at all what's going on since we have no rendering. Yeah. So that definitely, I mean, he's moving up. You can even see him move up, right? But for some reason, I can't go through here. Oh, you know why? I guess because these entities are not being three-dimensionally hit tested. So that's the next thing we have to do. Because if we have entities on here, we need them to actually be 3D hit tested. All right, so we're getting closer. This is kind of interesting. This is going to be really kind of fun for me because, like I said, I've never done a game that was purely 2D before. It's kind of fun working out how I want to handle things when you don't have actual 3D. You have kind of like pseudo 3D, and you want some amount of 3D, but you don't want it all. You don't want to have to go and actually have meshes in there for everything. It's pretty interesting. So yeah, so what's happening there is these entities are still blocking. So you need to kind of, like, you can imagine that test in here where we do the collision testing. We're testing against entities that are below you, and we're only doing two-dimensional collision testing. So no matter how far below it was, it's not going to actually work, right? And so you could almost think of it as like, the sort of weird version is like this, right? Entity PZ, right? Assuming that they're on the same z-plane, then they can actually be considered colliding with each other. Otherwise, they're not allowed to, right? Or something like this. Oops, that was a mistake. So if we did that, then in theory, you can do this and then walk through like so. And then if we wanted to go back down, we'd do that. And well, that didn't work either. That is how I would go back down, right? There we go. Guess I just didn't quite do it right. Yeah, so pretty janky. We've got a ways to go. Let's put it that way. But at least we're sort of getting there, right? We've got a little bit more happening now. And it's a little bit weird how this works, so we're going to have to kind of... Yeah, so basically, the other thing that we have here is, since gravity is letting the guy go down, we're not actually moving the guy down, we're just setting that ground and letting him sink through it. It's really more like letting him sink into the stairwell, which is why if you run over it quickly, you don't actually go down a level. And so we also probably want to treat it like a real stairwell and not have that ridiculousness happen, right? Because that's just kind of dumb. But that's kind of fun. So that's interesting. All right, I need to go to the Q&A. I'm kind of interested in here. Like I said, some parts I'm going to get a little carried away with because, like I said, if it's something that I don't normally work with on a day-to-day basis, then it actually becomes kind of intriguing to me too, and I'm liable to kind of get carried away. So we'll put it off. We'll start the Q&A, and we'll pick it up tomorrow. But I'm interested. It's going to be fun tomorrow. And in fact, I don't have to wait that long now that I think about it, because it's Friday, right? And that's a morning stream normally. So tomorrow it'll be 9 a.m. I won't have to wait that long, only 12 hours between now and then. So that's good. Is the familiar going to be programmed to be able to go through the stairwell or instantly teleported to the floor? I feel like the familiar should have to go through the stairwell. I think. I mean, I don't know. I feel like everyone should have to use the stairs unless they can fly. Like, if The familiar, since it's sort of flying, maybe it can fly up and down, like if there's holes between regions or something. I don't know. I don't know the answer to that question. That's a very good question, and I don't know the answer to it. So who knows? We'll see when we get there. When are we going to do priority for which sprite is in front and in the background? That'll be so you said I don't know what that's called. That's called sorting, really, or occlusion. I don't know. There's a number of things you could call it, but basically we're going to do that when we get to the renderer, probably. If you wanted to do it, it's not particularly hard, right? All you'd have to do is sort your entities by, and in fact, you don't even have to write it because I know, we're not really supposed to use libraries, so we'll write the sort ourselves. But if you didn't want to, you could actually use qsort to do it. There's actually one built into the C, in the C library. So if you look here, this thing will run a quick sort for you. And so if you wanted to do it ahead of when I do it, all you have to do is, instead of actually rendering the stuff, so I've already even set it up basically for you to do it. What happens is this push bitmap stuff, how we've got this piece group thing? That's just like a stopgap thing. Eventually what we'll do is we'll push all of the things we want to render. So they'll just be like an array, and all the things that need to get rendered go into it, and then they get sorted, right? And so basically that push, that piece where you're pushing things on, you just push those into a giant list, sort it, and then draw them. That's all you'd have to do, and then you're done. So it's really, really easy. The only reason we haven't done it yet is because I have to teach you how to write a sorting routine, which is, a sort of a couple-day thing to talk about and go through and whatever. And so, since it really isn't germane to the design, it's such a simple, basic idea. It's not something that we've had to address in order to do the rest of our work. You mentioned that you'll be able to attack from below above. Will you be able to do that on the stairwell? I think I said I didn't want you to do that. I mean, I want you to be able to, if there's something that's 2 floors high, like a giant boss monster, maybe you could do that, right? But I don't want there to be like attacking things below from up above, because it always felt weird. So unless there's a special thing that you like drop, or if you push something off a ledge, maybe that would be fine. But I don't like hitting downward. It always feels bad to me. And so hitting only happens like in the plane, in my opinion. So there's a question about if I already talked about programming entity systems. No, we haven't yet. We've talked about how we're doing our spatial handling of entities, how we're doing our update handling of entities, and also now how we're doing our sort of our collision processing of entities, which is sort of what we're doing. We're doing a little bit of that right now as well. But we have not actually talked about entity systems or how entities like really interact with each other. That will be a ways down the line, actually, because what I want to do is when we start that will be sort of the point of no return on game stuff, meaning when we start the entity system, we will go straight through to the end of the game. So we'll have all of our engine pieces in place except the entity system, and the entity system will be developed concurrently with the game and be expanded kind of over time. Does the scope of this application include moving environments? Yes. So we will probably do a fairly significant upgrade of the collision system when we decide that we're done with all of the sort of featurey sorts of stuff. So moving environments could be something that we put in. In fact, we could sort of play with that. I could put that on the to-do list here of things that we should play with, which we could do kind of, moving things pushing other things. Just call it that. Yeah. Will the game have color grading? Yes, we could totally have color grading. The blue and black cloak the hero wears may appear as two other colors in some lighting conditions. I'm telling you, that has nothing to do with lighting conditions, though. That's just the internet is messing with you. That's about surface reflectance, which is a totally different thing. It's not color grading. That was not a white balance problem. That was a reflectance plus white balance problem. Because something blue cannot appear gold through white balance alone, right? That's not going to happen. I mean, maybe if the white balance was full banana cakes, it would have to be the worst white balance in the history of time, I would think. But maybe not. I don't know. Maybe there's some really bad cameras out there. What are the piece groups and how are they useful for our current use in sprite rendering? So the idea is they're sort of a halfway house at the moment for our rendering. Because when we go to do the renderer, basically what will be happening is essentially what you see happening here with these piece groups. There won't be a group anymore per se. The piece group will actually just be a little thing that allows you to quickly assemble an entity together by sticking parts onto him, right? Like right now we had 3 parts to the hero, right? There's the torso, the cape, and the head. And so it's just a little thing that says, I'm putting together an entity, here's where the entity is. I don't want to keep having to add that offset in. The piece group's doing that, and it's also recording the things that need to get rendered. But in the future, it won't do that second thing. We probably won't call it a piece group anymore either necessarily. We'll call it like a coordinate system or something, I don't know. But in the renderer will actually be the thing that's recording everything that needs to get drawn. And then it will handle the sorting and culling and all that stuff that needs to happen. Can you please somehow unblank, swear has been removed, the net coding for DayZ standalone and finish what Dean Rocket Hall gave up on? So I will say, first of all, that I have never played or even seen DayZ standalone. I do not know who Dean Rocket Hall is, and I am the last person you want to go in and fix someone else's code, because usually I just get really grumpy and complain a lot. If you want someone to parachute in and fix someone else's code, there's really one man for that job, ladies and gentlemen, and that is Mike Sarton. So that is the person you should be asking, because he is the guy who does exactly that. He just parachutes into absolutely abysmal non-working code and turns it into something that functions. Will enemies follow you upstairs or down? Yeah. I don't see why not. If they do, how will the space outside the camera work? It should work exactly like the space inside the camera. Not sure what you mean by that. How will you handle sprite animation? Are you using a library, and have you ever heard of the Spine 2D skeletal animation framework? I have in passing heard of the Spine 2D skeletal animation framework, but I've never actually looked at it. For sprite animation, we'll probably be doing it mostly procedurally. But if for some reason we decide that we can't do it, some of it procedurally, I was considering doing like a little converter for Spriter, so you could make them in Spriter and output them. But I strongly suspect we'll be able to do everything procedurally. So I think all of the animation will probably be able to be procedural. And that's what I would like to do, because that allows me to teach a lot more programming. This is not, an animation This is not an animation class, so I would rather teach you guys how to program animations than teach you how to make them in a tool and read them, because that's pretty boring and pretty obvious how to do too. Who is that guy? Who is Mike Sarton? Mike Sarton, I don't know if you can find him, is this guy. No, that's not him. That's some other Mike Sarton. I don't know where he is. He's Mike. It's just Mike Sart on Twitter. I don't know why I can't find him. There he is. That's him. And this is him too, finding bugs in the Linux kernel. He was one of the main guys who did. There it is. That's him. So he's like a guy. He works at Valve. He used to work at Rad. He did a bunch of the Steam Linux stuff. He fixed like a bunch of stuff in the Team Fortress 2 server that was busted. He fixed a bunch of stuff in the Dota servers. Like he parachutes into a lot of stuff when people are like, we don't know what's going on. And he's like, I got this. So you know, he's the guy who came to mind where I was just like, if you're gonna try and convince someone to save you on a project, it ain't me, because I just get grumpy and complain a lot, and that doesn't fix the problem, right? I'm mostly the guy who writes stuff from scratch or totally new code, right? I'm that guy. I'm not the guy who comes in and holds his nose and then like actually figures out what's wrong and fixes it all. So Jack Krauser, I'm still not sure what you mean when you say, I mean with there being different floors, will it be different? I'm assuming not. Yeah, I mean, my conceptualization of the world so far is that we want to make it as rich as possible just because it's harder to program. So if enemies can follow you up and down stairs or decide to go up and down stairs themselves, that's just harder programming for us. So I think we should do it because it forces me to have to do more stuff, which lets you guys see how to do more stuff and how I approach it, right? So that's really why I make decisions that way. I don't think there's necessarily gameplay reasons why enemies have to go up and down stairs. And if we found that we were taking too much time and we have to cut features, we could cut something like that, right? So that's fine too. But it's just, that's usually the way I look at it. It's like, well, is it easier or harder to program if they can go up and down stairs? It's harder to program if the enemies can go up and down stairs, so let's make them go up and down stairs. Can you run this game so some of us can see its current state? Oh, well, we haven't really done any game stuff yet, so it's not particularly interesting. And I probably would have to switch to single level to do that. Really all we did is we're just working on our spatial partition stuff and our entity collisions and that sort of stuff. We're basically working on the engine. So there's not really a game to show per se. But if we were to take out sort of the up and down stuff, I guess, for lack of a better term, we should probably make an if for that. But basically, if we were going to do that, we would have to do, let's see, where we do the 3 thing. We'd have to basically if zero this out, right? We'd have to do something like this. We did this before. Because right now we're making multi-floor things. So we do that, I think, so it can only ever pick the other one. I'm not sure if that's right, but we'll see. So basically, yeah, all we were doing was we were just trying to make some basic stuff. So we started out, we made some tile map stuff, and then we extended our tile map, so now we don't have a tile map up anymore. We actually just have entities, but we left them in sort of a tile mappy sort of configuration. They don't actually have to be there. You can put stuff anywhere you want. We haven't really put much art assets in, so we're drawing trees, even though, yeah, we're just drawing trees. And anyway, you know, we can make rooms and walk between them and all that sort of stuff. We haven't done the renderer yet. This is basically, we wrote a temporary renderer. So that's why things don't sort. For example, you notice if I go behind this tree, like that doesn't make any sense. I should be in front of it. That was the thing we were talking about earlier on the Q&A about sorting, right? We added projectiles in, and we tested that you could only have one of them and that sort of stuff. We added hit points in, so you can attack things. I think there's a monster back here. Oh, this little guy we made who follows you around, right? That was just testing having like a familiar, kind of a thing. So you can, attack things and they lose hit points, whatever. But again, like this isn't game stuff yet. What we're doing, since the point of the stream is to do everything from scratch, it's the opposite of go grab Unity and drop some stuff in, right? We're not doing that. What we're trying to do is do the whole game from scratch so people can see how to write a renderer, how to write a sound system, a music system, like all of these things. And so what we've been doing here is working on our architecture, and I've been trying to show everyone how you build all of the parts of a game and how they interact. And we've been making pretty good progress on that. We've still got a ways to go, though. You can kind of see we've got our little to-do list here, right? Which is the stuff we want to work on. We want to make a little debugging system. That's our next big thing we'll probably do. Then we want to do some audio mixing and that sort of stuff. We want to do asset streaming, put in some metagame stuff, figure out how the world gets generated, and then some AI, pathfinding and fighting. Then we will do our main game pass, which is basically like doing animation, figuring out how we want that to work, then doing the real renderer, and then starting on the full final game, like that's the code that ships from then on, right? And so, that's what it says. We only do an hour a day, so it's very slow. Right now, we're on day 74. That's only 74 hours of coding. It's not even 2 work weeks yet, right? If you work a 40-hour week, we haven't even done 2 weeks worth of programming, so it's not a whole lot of programming. But I've been pretty happy with where we've been at, so, I'm pretty happy with it. But like I said, there's no game to show yet, so, come back in 50 days, there'll be more. Okay, so you know how we have the camera space, and then there's a space outside that we can't see, but entities are still moving. Well, we need to edit that code to make it work on vertical floors. It's okay if you don't get it. I may be thinking too far in. No, so the answer is that there's no difference now between the code that runs in the place you can see and in the space that you can't see. The only difference is we will probably update the space you can't see less frequently, right? But the code's the same. So when we write the code for monsters moving up and down the stairwells, when you can see them, that's the same code they'll use when you can't see them. So we won't really have to do anything there probably. Now, if we have to optimize what happens when you can't see them because because it's too slow, and we need to get that throughput up for the non-visible stuff, then we might have to make special concessions, right? But until we hit that performance, that hard performance limit, it'll just be running the same code, so we don't have to worry about it. If it works on camera, it'll work off camera. Would we use a fixed discrete animation for moving up and down stairs a la Link to the Past, or would the goal be to make the movement seamless? Seamless. Absolutely. I hate it when the movement of my guy is not under my direct control. The hero sprite will be under your direct control at all times unless like a monster has grabbed you and you are not able to move because you're being like restrained or something. But like none of these canned animation nonsenses. Like you'll always be in control of the guy because it feels awful. I hate it when you walk up to a door and like it plays this like go through the door animation. Especially if I didn't want to go through the door and now I have to wait for that. Then I have to go into the door and wait again when I should have just been able to like push back and not go through the door. So yeah, definitely not. Always seamless. That's like a hard requirement. Always seamless. How much lines of code you have at the moment? So Sean Blow gave us a thing that we could use to count it, but it's not very large. Oops. Is that how you do it? It's pretty small, 4,500. So we're averaging something like, I guess, what's that? Like 50 lines an hour, something like that. Not particularly much. I mean, like I said, I gotta explain everything, so we don't code very fast on the stream. All right, that is the end. It looks like the end of the Q&A as well. Good deal, people. So tomorrow I think we clearly have our work specified for us. It's time to like play around with that code and get it working well and nicely. We're gonna have to do something. I should put this back to the state that it was in before we did our little quote-unquote demo there. And also, I suppose I should do inside that sim region. We had the did we actually didn't we have our should collide thing is kind of busted now? Yeah. So we have this right here that we need to think about as well, right? And we need to figure out how we want to do that. So I guess what we need to say tomorrow is basically like let's go ahead and let's go ahead and say move this back up here. We got to sort through our list. Maybe tomorrow's a Friday too, so that'd be a good day to do it. What I would like to do is say 3D collision detection working properly should be something we should go ahead and actually give our guys Z ranges, basically. So let's do that. Let's do that tomorrow. So that brings us to the end of our Handmade hero. I'm going to close things down here, and we'll save our Blackboard. There we go. There we are. No, go down, down. Okay. So thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always pre-order the game, and it comes with a source code, which you can download every night after I'm done coding. And of course, we have videos covering every last line of it, so you can learn about absolutely anything that we've done so far and play around with it yourself. It also comes with the test assets I use on the stream. So if you want to do that, head over to handmadehero.org, and the handy-dandy pre-order button will hook you up. We also have a Patreon if you just want to support the video series because you are a nice sort of folks. We have a Patreon you can subscribe to. That's also linked off there. We have a tweet bot now that tweets the schedule at you, and that's a pretty handy way to keep informed of when the stream is if you want to know ahead of time instead of having to wait for the Twitch emails, which kind of are at the last minute. The tweet bot will tell you what the schedule for the week is and what the schedule for the day is, so that's pretty handy. And then there's the news and forums site, which has a bunch of great stuff on it, community maintained. It's got some good things on there like ports to Mac and Linux. If you want to follow along on a different platform, you can do that there. There's an episode guide that's annotated, it's really nice, and there's a place to ask questions, like a forums thing you can use, and I answer questions on there, as do other people in the community who are experienced programmers, so it's pretty good. So I highly recommend checking it out if you try to learn from the stream. Tomorrow will be early morning, I believe, because it's Friday, right? It's a Friday, and that means the stream is at 9 a.m. Pacific Standard Time. So I don't know if those of you who have a little breakfast coding you might want to do can join me for that. Should be pretty fun. So I hope to see you tomorrow. If not, have a wonderful weekend, and I'll see you back here. Oh, no, I won't. And that'll be it for a week, because I said we'd take next week off, if I remember correctly. Is that right? First week of March? Yeah, first week of March. So this will be the first week that I don't see you. Well, I'll miss you, but we'll be back here the second week of March, and I hope to see you all back then. All right, take it easy, everyone.